again. This is a regular hexagon because it has 6 sides. And trust me that they're all equal, right? I'm not perfect. But they are because I told you it was regular. Regular shapes have centers. Okay? They also have these 2 lines that go from the center out to the sides, okay, or out to the outside of the shape. Okay? And one of those things is called an apothem. And that's the one that goes from the center to a side at a 90-degree angle. Okay? So we've got one there, we've got one there, we've got one there, we've got one there. We have the same number of apothems as we do sides, right? All of those are apothems. Typically, I'll only give you one because that is just a nightmare to look at, right? So let me erase these because we don't need you. If we know one, we have them all because all apothems are equal. All of those apothems are equal because it's a regular shape. Cool. One benefit about the smartboard is it has the undo button, which is nice. Okay, cool. So this is an apothem, so let's call it A. You know about perimeter, right? Just the outside all added up. So if this was 3, 3, 3, 3, 3, 3, 3, because they're all, it's regular, they're all equal. 3 times 3, or 3 plus 3 plus 3 plus 3 plus 3 plus 3, or 3 times 6, because there's 6 sides. What's the perimeter of this thing? 18 units, right? Do we understand how I got that? Yep. Okay, so the area of a regular polygon is 1/2 A, which is our apothem, times P, 1/2 AP. Cool. So if I gave you that A was equal to 5, well, let's do a different number. Let's say A is equal to 6. You would know that the area is what? What's the area of this thing? 6 times 3, right, which is 18, times 1/2, which is just 9, right? 18 divided in half is just 9. So the area here is 9 units.
What's P stand for?
Perimeter.
Wait.
Perimeter.
So once you do it times 18, not times 3?
Oh, you're right, you're right. What am I doing? What am I doing? What am I doing? A, which is 6, P, which is 18. 6 times 18. Anybody? Bueller? 108. Divided in half is 54. So the area is 54 units squared. Thank you. Thank you. Yeah. All those added up. Not just this guy. All of these added up. Okay? Great question. All right, so not too bad if I give you those. I'm not going to give you all of those. What I am going to do is I will probably give you the apothem. So I might say the apothem is 2. But I don't give you these. How do we find the perimeter? Trig. Draw yourself a triangle. A line from the center to a corner is a radius. Okay? Is that super important to know? Not really. But there's a line. Radii are equal. So now I've got a big triangle set up, right? Cool. If I can find the bottom here, then I've got a side and I can find the perimeter, right? Cool. Now, we can't do much with this if we're trying to use P-tag, right? We don't know any of these sides. That's a nightmare. But what we could do is do trig. Trig only works with right triangles, though. There's my right triangle. So if we can find this part right here, we can double that and find the whole thing, right? Okay, so that's my plan of attack. So let's do this. We've got a triangle. Let me draw him over here so we're just thinking about the triangle instead of seeing all that. So we've got an apothem, which we said was 2, right? I'll draw him on the outside, 2. Right angle. We've got this piece right here, and then we've got our radius in green, okay? Let's label this thing. Which of these is my hypotenuse? Green is hypotenuse. We don't know opposite or adjacent yet because we haven't picked a side to put theta in, okay? We don't know any angles except this guy. We need to find one of these 2 angles. How do we do that? Well, we got to find this guy, which is going to be half of this guy, isn't it?
Yep.
All right, so how do we find the big guy? How many angles total do I have in here?
360.
360. If we divide it into 6, right, 6 sides, we can find the big guy. Divided by 6 is 60 degrees. So the big guy is 60 degrees. What's the little guy?
30.
30. So this guy's 30. Now we're in business. We could know that this is 60, right? We've got a special triangle. Maybe you like special triangles. Maybe you hate them. You don't need to know that. As long as you've got one angle, you're fine, other than the 90. Okay? So we can set up SOHCAHTOA now. SOHCAHTOA. Always write it down. Helps me, could help you. So we know if we're going to put theta in here, because this is the angle we know, right? Put theta in 30. Which one's the opposite side? Black side, right? That's our opposite. That's our hypotenuse. This is adjacent. Let's set up an equation. Which one is going to deal with the thing we know and the thing we want to find? We want to find this side, right? So we want opposite and adjacent in the same equation. Which one has O and A in it? TOA means tangent of your angle. What's our angle? What's our angle? 30 degrees. You're scaring me. Equals opposite over adjacent. Do we know our opposite? Op. We don't know. Adjacent we do, which is 2. If you want to call opposite x, that's fine too, right? Maybe that's easier. It's the side we're missing, side x. Now we solve. How do we get 2 over here?
Multiply by 2.
So now we have 2 tangent of 30 equals x. Plug that in your calculator, find out what x is. 2 tangent of 30 equals what? 155 if we round up, right? 1.155. Now we found this guy, but we want the whole thing. So what do we got to do to get this little piece to be the whole thing?
Multiply by 2.
All right, cool. So 1.155 times 2, which is going to get us 2.31. So this piece right here is 2.31. How do we find the perimeter?
Yeah.
Multiply by the number of
Multiply by
sides. 6 times 6. P is 13.86. How do we find the area? Half times the A, which is
2.
times perimeter, which we found was 13.86. Do the math. 13.86 times 2 divided by 2. It's 13.86. It just so happens that these two cancel out, right? If our apothem was 3, that would change things, right? So cool. That's our area. Units squared whenever we talk about area. So all that work, but once you get the equation set up, it's not so bad. But do you see you got to find the right triangle, set it up, find this, multiply by 2, do your thing. The hardest part, I think, is remembering that you have to figure out the angles, right? And all it is 360 divided by the number of sides is the big angle, and this guy's going to be half of that. That's all. I'm only giving you nice ones, so you won't get like 7.25 over here and have to divide that in half and do weird things, right? They're gonna be nice numbers, okay? Do you think you can do this?
Maybe.
Good, all right, we got that on camera. All right, so you're super confident about this. Would you like me to do another one, or would you like me to move on? Okay,
Move on.
all right, I figured. You've got it on tape. If you want to go back through it, I'll have that uploaded by the end of tonight. You guys have your final on Tuesday, yes? So you've got time. And you've got the other one to look at too, because I did the same thing basically with them. Different problems, so if you want another example, that's the way to do it. Okay, so P&A of regular polygons. This is really easy. We spent like 5 minutes discussing it because it takes up so little time. So perimeter and area of regular polygons, finding the relationship. So if I give you a polygon, like this guy, and this guy, and I say they're similar, okay? And I label all the sides out. This is 3, this is 2. Well, let's do something that's realistic, I guess. This is 5, this is 4, and this is 3. And I'm telling you, this is similar, okay? And that this guy is 2. No, let's do it this way. This guy is 8. Now this guy's bigger. Okay. Will it work? Yes, but I want to make it look nice. This guy's smaller, right? So he should be smaller than him. How about we do this? This is 8, this is 6, and this is 10. And I tell you, this guy is similar, and this length is 3. What's this side going to be? 4. What's this one going to be? 5. So we see the relationship here. This side is 2 times bigger than this guy. So we have a 2-to-1 ratio, right?
Yep.
Okay, cool. So if I were to ask you about the ratio of their perimeters, so P1 to P2, this is perimeter 1, triangle 1, and triangle 2, okay? You would know it's the exact same thing. If you didn't know that, you could figure it out. 8 plus 6 plus 10, 24. 3 plus 4 plus 5, 12. 24 to 12, 2 to 1, right? So the perimeter ratio is the same as their side ratio. That's it. So if I ask you for the ratio of the perimeters, you got it. What if I ask you about the ratio of their areas? You could do the thing and solve for their areas and compare them. Or you could know that whatever your perimeter ratio is, which is the same as your side ratio, right? 6 to 3, right? It's that squared. Because it's area.
Those numbers squared.
Square it. 2 squared is
4.
4. 1 squared is 1. That was an entire section in your book.
So area is squared.
The perimeter ratio squared. And perimeter ratio is just your side ratio. And you could prove that, right? You could find the area of this triangle, base times height divided by 2, right? And compare them. But you'll get a 4-to-1 ratio. This ratio squared. If this ratio was different, well then we'd square that and get whatever this guy is, right? You just square the perimeter ratio. And you can find missing sides, right? We did that. If I give you this and I say, hey, what's the missing side length? You would see, oh, 10 to 5, 6 to 3, 8 to 4. Pretty easy, right? Okay. And they told me ratios would be hard. That's it. So I gave you 2 free problems on that, basically. Right? That's 4 points right there at least that you just got for free.